Hello everyone. Today I want to discuss about the topic about importance of calibration and verification in a clinical lab. I want to discuss this topic under following subheadings which include introduction, total quality management framework, quality systems, quality control, quality assurance, calibration. It includes types, instrument calibration, procedure, error certificates, and verification. Calibration and verification come under the analytical variables in quality control. So first of all, we discuss about the total quality management framework. It includes quality labor process (QLPS), quality assurance (QAS), quality assessment (QA), quality control (QC), quality planning (QP), quality improvement (QI). The main objective of a laboratory is to provide reliable, timely, and accurate test results. This is only possible through consistent monitoring and evaluation of the laboratory's performance. To implement and follow up of corrective actions for non-conformance to procedure. The establishment and continuous monitoring of quality systems in each testing laboratory is required for reliable and robust testing. So we talk about quality assessments. It is used to provide the assurance of the quality of the test result. It ensures that the lab operations are coordinated, organized, and standardized. These are act as a tools to monitor performance. Quality control, which is internal quality control, plus quality assessment, which is external quality assessment, comes under quality systems. Then quality assurance is also a main part of the quality systems. So when we talk about the quality control and quality assurance, quality control refers to operational techniques performed during each assay which is run to verify that the requirements for quality are met with. Quality assurance (QAS) refers to all the planned and systematic activities to provide confidence that the results given out by the laboratory are correct. The aim of quality control is to ensure that the results generated by the tests are correct. So quality assurance (QAS) is concerned with that the right test is carried out on the right specimen and the right result and the right interpretation is delivered to the person at the right time. So this is the quality assurance cycle which is include the three phases: pre-analytical, analytical, and post-analytical phases. So the pre-analytical phase, which includes the patient or client preparations, the sample collection mainly, then sample is transported to the particular laboratory where the testing is performed. The sample is received and accessed. That is, sample which is received at the laboratory should be written in a prescription or the samples collected notes. Then the personal competency tests evaluation, quality control testing should be done, which is included under the analytical phase of the quality assurance cycle. Then the tests which are done and the report which is generated is to be kept in a record and it is to be given to the patient. So the sample which is collected, transported, received at the laboratory is included under the pre-analytical phase. Sample which is tested and it is tested under the quality control management is included under the analytical phase, and the sample which is tested is to be given the result, and the result which is given is kept in a records for the future reference. So this comes under the post-analytical phase. So pre-analytical, analytical, and the post-analytical phases of the quality assurance cycle is very important to remember. So most of the errors in this quality assurance cycle is to be mentioned or to be done in pre-analytical phases, where the barcode of the uh, client sample which is received is to most of the times is recorded as the wrong one, or the age of the patient or the sex of the patient is recorded mostly as the uh, wrong thing. Okay, so this is about the quality assurance cycle. So we have to be careful in the pre-analytical phase. So commonly the errors that occur in the laboratory, which include analytical measurement errors, which where the instrument not calibrated correctly, specimen mix-up is there, incorrect volume of the specimen, interfering substance present, instrument precision problem. So these are the common errors which occur in the laboratory, where the quality assurance cannot be maintained. Factors influencing analytical variables: use of appropriate controls, which are internal or external ones. Internals, which include labs calibrated against national things, and external supplied by the manufacturer, national, international uh, factors. So we have to calibrate the instrument very regularly to get the results accurately. So what is calibration? It is defined as the process of testing and adjusting the instrument in order to establish a correlation between instrument's measurement of the substance which is being tested and the actual concentration of the substance. So this is the definition of the calibration. It helps to assure that the instrument readings are accurate with reference to the established standards. It adjusts the precision and accuracy of measurement of the equipment. So this is about the calibration. Remember, calibration is the foundation of all clinical laboratory testing that ensures the accurate testing of patient results. Calibration links analytical signal with the concentration of analyte which is present in the serum, urine, or other body fluid. This is the analytical measurement range. So, short form it is known as AMR. The calibration function is the relation between the instrument signal and the concentration of analyte. So instrument signal is taken as y, or and the concentration of analyte taken as x. So when we measure the calibration, we take the formula as y is equal to f into x, or x is equal to f1 into y. It is set of operations that establish the relationship between values of quantities which is indicated by the instrument and the corresponding values realized by the measurement standards. So for every test to be get accurately, the calibration should be done constantly. Calibration function may be linear or curved graphically. In automated clinical chemistry instruments, the relationship between the analyte concentrate and the signal is often very stable. In high performance liquid chromatography, it is customary to calibrate each analytical run. So this is the calibration curve which plot showing the limit of detection LOD and limit of quantification, the dynamic range, and the limit of linearity. So this is about the um, calibration curve, where the x-axis is taken as concentration and y-axis is taken as the signal. Calibrators are the reference materials. It has substance of known concentration, and it is used to adjust instrument kit test system in order to standardize the assay. Sometimes called as a standard, although usually not a true standard, and this is not a control. So types of calibration, it includes annual calibration, measurement calibration. So measurement calibration, which is daily used as daily calibration. So talk about instrument calibration. It is intended to eliminate or reduce bias in an instrument reading over a range for all continuous values. Why calibration is important in scientific laboratory? It minimizes the measurement uncertainty by ensuring the accuracy of the test equipment. Key advantages of accredited lab equipment calibration services. So generally the labs are accredited by the NABL, that is the National Accredited Board of Laboratories. So when these labs are accredited, there is the strict adherence of high standards unmatched accuracy, meticulous monitoring, exceptional level of control, reduced cost. So these are the key advantages when a lab get accreditation. Calibration procedure, it varies from product to product. Types of calibration, traceable calibration, UCAS calibration. Traceable calibration, it refers instrument against the pre-calibrated devices. UCAS calibration, which is performed by a laboratory which has UCAS accreditation, and it is a fulfilled requirement of ISO or IEC. Then how we can measure the calibration error or calculate the calibration error? It is calculated as percentage error is equal to accepted value minus experimental value by accepted value, which is multiplied by 100. Calibration error is an instrument error, the difference between values indicated by an instrument and those that are actual. So already told about how to measure a calibration error. It is percentage error is equal to accepted value by x minus experimental value by accepted value multiplied by 100. Calibration certificate. It documents essential information about the instrument's condition. It provides a detail about tolerance conditions. Each certificate includes a serial number that associates one calibration with one instrument. It provides that an instrument has been checked and verified against critical points of measurements. Calibration of automated blood cell counters. Use of fresh normal blood specimens to which values have been assigned for hemoglobin, packed cell volume, red blood cell count, white blood cell count, platelet count by standardized reference methods. Procedure to assign values to fresh blood indirectly to stable a calibrant. 4 ml of blood is collected from 3 normal volunteers and anticoagulated with K2E2A. Hemoglobinocide method. Mean of two measurements taken for measuring the hemoglobin. Hematocrit microhematocrit method is used for measurement of this, where mean of 4 tubes are taken. RBC single channel aperture impedance counter is taken, where mean of 2 dilution each counted twice. So serum vitamin B12, folate, red cell folate, these are gravimetrically prepared cyanocobalamin. Used lyophilized serum standard. Used 3 FFP with assigned 5 methyl tetrahydrofolate folic acid homocysteine, which is used for measuring the above values. Procedure to assign values to fresh blood indirectly to a stable calibrant, where MCV is measured by calculated from the RBC and PCV. WBC is measured by single channel aperture incidence, made mean of two dilutions, each counted twice is taken into account. Platelet count is done by flow cytometry. To calibrate the automated counter directly from 3 fresh blood samples, 2 counts with each sample are performed, where mean of 2 values are taken. If the measured counts differ from the assigned, recalibration of the counter is needed. Corrected calibrated value is taken as this formula ACAFDF in the formula, which is abbreviated as AC is measurement of calibrated by automated counter. AF is abbreviated as measurement of fresh blood by automated counter. DF is calibrated as direct measurement of fresh blood samples. For calibrating micropipettes, we include the following: commercial photometric pipette calibration products, calibration service providers, pipette trackers. When to do calibration? At installation of the instrument after replacement of any component that involve dilution characteristics. Then verification. It refers to the ability to make sure that the test method used conforms to the manufacturer specifications. It is done periodically to ensure that the instrument is working as it should be. Provides objective evidence that the given instrument fulfills specified requirements. This is about the verification. So combination of the calibration and verification, it means assigning materials of known concentration in the same manner as patient samples to substantiate the instrument or test system calibration throughout the reportable range for the patient test results. So this is about the calibration verification graph. How often is calibration verification is required? At least once every 6 months when complete change of reagent, replacement of critical parts, control results indicate problem in the test system, environmental changes, instruments replacement. So this is the period where calibration verification is required. So this is about the graphs showing the measured value, that is illustration of results distribution showing the mean value and expected imprecision for repeated measurements of quality control sample where the standard deviation is taken into account. So on x-axis imprecision is taken, on y-axis number of replicates is taken, and the mean average value is taken as one standard deviation or two standard deviations. So this is graph showing illustration of systematic bias when a change in calibration has occurred. So the shift of the graph is seen to the right side, where on x-axis and y-axis are the same number of replicates, number of impression, and so take-home message is like this: calibration and verification come under the analytical variables in quality control, which includes the total quality management framework, and this TQM includes these QLPS, QAS, QA, QC, QP, QI. Thank you very much.